minima of x power x function. For this function, we need to find the minimum value of this. If I put x equals to 0, then it becomes 0 power 0. If I assume that my function y equals to x power x, then y equals to 0 power 0. The value of 0 power 0 is 1. This is the value of x power x. But is this the minimum value of the function x power x? Let us try to understand this by plotting a graph here. If I plot the graph of x power x, I got a curve which is increasing from certain value. Initially at x equals to 0, the value is 1. As I increase the value of x, it increased till this point. At x equals to somewhere between 0 and 0.5, between these two values, my x got decreased and suddenly it just started increasing along this curve. But where exactly is the point where my curve is increasing? These points where the curves start increasing or decreasing, it is called as stationary point. To understand this point, let us try to understand the differentiation first. If I take the function y equals to x power x and differentiate this, y equals to x power x. To find the differentiation of x power x, we have no formula for this. Let us try to apply logarithms on both sides. Log y equals to log of x power x. Applying differentiation on both sides, differentiation of log y equals to 1 by y into dy by dx, which equals to this function here, it becomes x into log x. It is a product of two functions x and log x. We need to apply UV rule here. Differentiation of x is 1 and differentiation of, we need to differentiate x first and into log x plus x into differentiation of log x is 1 by x, which is equals to log x plus 1. Dy by dx here becomes y into 1 plus log x or log x plus 1. Substituting back the value of x, value of y here, where y equals to x power x, dy by dx will become x power x into 1 plus log x. This is the differentiation of the function x power x. But how can I find the minimum value? Coming back to the graph, at this point, if I draw tangent to this curve, at the lowest point of this curve, if I draw the tangent, it will be parallel to the x-axis. In the sense, my tangent at this point is horizontal. The slope, the dy by dx, indicates the slope of the curve. This is nothing but this slope, and the slope is becoming 0 over there. From this, that implies my function dy by dx, x power x into 1 plus log x equals to 0. For this total expression to be equals to 0, 1 plus log x equals to 0. So log x equals to minus 1 and x equals to, if I remove the logarithm, I get the base e power minus 1, which is equals to 1 by e. So x equals to 1 by e. At x equals to 1 by e, I get the minimum value of the graph. If I give the input as x equals to 1 by e here, at this point I get this minimum value. at x equals to 1 by e, y will be equals to y will be equals to 1 by e power 1 by e. At this coordinate, I have the minimum value. So y equals to 1 by e power